Okay, next step on our journey, we're now going to get into complex sorting. It's pretty exciting because this is, as I said, this is one of the most difficult things to understand at first go. But I think you're making good progress, so let's see how it goes. Right now, I'm going to show you a problem with sorting that you may have to confront from time to time. The default sort actually isn't alphabetic. It looked alphabetic before, but take a look at what happens when I sort these differently cased strings. Can you see from the result exactly how the sorted occurred? Maybe pause the video and take a stare at it and see if you see any pattern. Okay, well, you have noticed that they're not in alphabetical order. That's definitely the case. You may have also noticed that the uppercase and lowercase items were grouped together. Interesting clue. Then you may have further noticed that within the case, they are alphabetically sorted. So B, D, and F have been sorted together. A, C, and E have also been sorted together. And actually, I think I'm going to change the order here. Okay, I just changed the order just for the hell of it, just so that it wasn't in order to begin with. But we get the same sort order. The uppercase letters were sorted first. They were sorted correctly among themselves, and the lowercase letters were also sorted correctly among themselves. So what gives? Exactly why does sorting work this way? Well, the answer is that default sorting doesn't actually use letters and alphabetic comparisons in order to order string items. It actually uses something called the ASCII table. The ASCII table is a special table of characters. It's been in use for decades, since the early days of shared computing. And the ASCII table basically maps each character to a decimal number. So the capital A is at decimal 65, but the lowercase a is at decimal 97. Within the case, you can see that all of these letters are numbered sequentially. So I hope that's starting to make it clear exactly why uppercase letters would come before lowercase letters. It's because when Python sorts strings, it's actually sorting their integer equivalent. Now, that's not going to be so important to our analysis. What's really important, though, is how are we going to handle this? So the fact that it's the ASCII table is not really that important. I just wanted to explain why it's happening this way. For our purposes, though, if we're interested in an alphabetic sort, what could we do? Well, one thing we could potentially do is change all the items to the same case so that they sort properly. We could use map for that purpose, right? Obviously, if I wanted to lowercase every letter, I would just say map and then I would say stir.lower, or I would write a function that takes the string and returns the lowercase string. I could do that. But instead, I would prefer that we sort these strings in place using their current values, but I would like the sort to happen alphabetically rather than ASCII-betically, as they sometimes say. In other words, I don't want it to use the ASCII table, or really what I want to do is influence the sort so that it becomes alphabetic, or so that the effect is alphabetic. So here's the question for you, and this would be another pauser for you. What function could I apply to each item so that when sorted, they come out alphabetically? That would be the problem, because that is the solution. The solution is to use a function. We're going to use a function on each item, and we're going to demonstrate how sorted makes use of that function. So pause the video and ask yourself, if I could apply one function to every item so that they all sort alphabetically, given the rules that you understand, that is, that Python cares about case when it's sorting, what function could I use? Okay, did you consider the lower function? I know we even mentioned it a little earlier in this video. Yes, the lower function will do it. And what I'd like to do is write a function that lowercases letters. So I'm going to go ahead and assume I'm going to get a string, and I'll return arg.lower. So there's my function. Just like the other small function, the doubler or tripler that I showed you earlier, it's a function that does one little job. It takes a string and it lowercases that string. Of course, we do have a method for that purpose. I'm going to use a function just for illustration purposes. I need to apply a function to each item so that they sort properly. And the way I do that using sorted is I reference the function using the key equals argument. What this has done is it has allowed me to sort the items in place as they were, in other words, without changing them at all, and sort them by a different value. So key equals allows us to apply a function to each item for the purposes of sorting. When I say for the purposes, I mean, yeah, we want to sort the F character, but I don't want to sort it as an uppercase F because that would place it ahead of the C. I want it to sort as a lowercase f. Now you'll look at the result and see that the items actually haven't changed. So we have an extra piece of magic going on here. First off, let's apply the same concept that we applied to map to sorted. The concept that we applied to map was that every item gets a function applied to it, right? Every item gets a function applied to it. In fact, let's just say this. The concept with map is that a function will be applied to each item, and the result will be that value that came back from the function. The concept with sorted key equals is a function will be applied to each item for the purposes of sorting. What that means is that the function is not changing the item, but it is kind of temporarily looking at the item differently. In other words, once we apply lower to everything, what are we actually seeming to sort? We're seeming to sort all the lowercase items. Why? Because the lower function, our little lower function, was applied to every item. And if we sort them alphabetically using lowercase strings, then yeah, they're going to sort alphabetically. That's going to work. Now, it's true that the item isn't actually getting changed. It's sort of getting changed temporarily. Here, there we go. It's sort of getting changed temporarily. There we go. It's getting changed. Oh, that's not what I want. There we go. No, oh well. It's getting changed temporarily so that we can sort each item. But it's not actually being changed. It's just being, there's a separate value getting generated for the purposes of sorting. You can see that the result is the same letters that we started with, but they've been sorted alphabetically because of the application of this function. So now if we were to compare sorted to map, we see that both map and sorted do take a function as an argument. And sorted, it looks a little different because it's something we call a keyword argument, and we don't really need to worry about that. The main idea, though, is that both sorted and map take lower as a function, and they apply it differently, but both of them apply it to each item individually. So in the case of map, it just produces a new list in the same order with each item changed. That's what map does. It applies the function to each item. But sorted doesn't do that. Sorted applies the function to each item for the purposes of sorting. That's a really important distinction. that first off, any function that we use with sorted is not designed to work with the whole list. It applies itself to each item for the purposes of sorting. So now capital F is being sorted by its lowercase equivalent, capital D by its lowercase equivalent, lowercase c by itself, capital B by its lowercase equivalent. These items are being sorted as if they were lowercase. They haven't changed. They've just been sorted as if they had. And that's how sorted functions work. And in the next videos, we'll look at some additional examples.